So we're looking at sequences. What are sequences? Well, sequences are used a lot in real life, and a lot of the time we don't see them outwardly. But you use sequences when you put any information into a computer, and it encrypts it. It actually does it using a sequence. So it's code breaking, it's code making. You see sequences all the time throughout real life as well. A Fibonacci sequence is a really famous sequence, and we see it in nature. We see it from flower petals to the spiral of a galaxy, to weather formations. So sequences are all around us, so it's important that we understand a little bit of how to manipulate them and how to use them. So we'll look at a couple of examples, and we'll look at a couple of the different things they can ask us in our GCSE exam. So one of the first things they can do is ask us to continue a sequence. So if I was given the numbers 3, 8, 13, and 18, the question might be, what are the next three numbers in this sequence? So I look at this sequence and I notice that to get from 3 to 8, I have to add 5. To get to 8 to 13, I have to add 5, and to get from 13 to 18, I have to add 5, which means the next term in my sequence, I'll just have to add 5. 18 plus 5 gives me 23. The next one then will be add 5 again, which will be 28, and the last one will be add 5 again, which will be 33. So another example of that, well, what about if I started with 25, 21, 17, 13. Now you might notice this is a bit different because instead of going up, this sequence is in fact going down by 4. So 21 to 17 is minus 4, 17 to 13 is minus 4, 13 to my next number will be minus 4. So the next term of the sequence will be 9. Take away 4 is 5, take away 4 is 1. So there's the next three terms of that sequence. So now that we've looked at adding and subtracting, what about this sequence? We've got 1, 2, 4, 8. Now what I notice is this sequence isn't going up in a linear fashion. That is to say that the difference isn't the same every time. So how do I get 1 from 1 to 2? Well, I double it. How do I get from 2 to 4? I double it. 4 to 8, I double it. So 8 to the next term, I double, which would be 16. Next would be 32. And finally would be 64. Next then, we'll look at generating sequences. We've looked at continuing sequences. When I generate a sequence, for example, if I was given 4n and I was asked to generate the first 5 terms of that sequence, well, n stands for the term of the sequence. So when n equals 1, I get the first term. So if you remember, a number next to a letter means multiply. So 4 times 1 is 4, so the first term is 4. Then when n equals 2, I get the second term, so 4 times 2 is 8. The third term is when n equals 3, 4 times 3 is 12. The fourth when n equals 4, so 4 times 4 is 16. And the fifth one when n equals 5, which would give me 20. So there's the first 5 terms of a sequence generated by 4n. What about 4n plus 1 then? Well, again, n is the term of the sequence. The first term is when n equals 1. 4 times 1 is 4, plus 1 is 5. The second one would be 4 times 2 plus 1, which is 9. The third one would be 4 times 3, which is 12, plus 1, which is 13. Then it would be 17, and then it would be 21. So, nice and simple. What about then, we'll look at one last one, and this time we'll say 5n take away 3. Well, again, when n equals 1, 5 times 1 is 5, take away 3 is going to give me 2. When n equals 2, 10 take away 3 is 7. When n equals 3, 15 take away 3 is 12. When n equals 4, 20 take away 3 is 17. And when n equals 5, 25 take away 3 is 22. And now we've looked at completing a sequence, generating a sequence when we're given the term, we'll actually look at finding the terms of the sequence. So what that means is we're given a sequence, so we'll look at the sequence 2, 9, 16, 23, etc. Now I'm looking for the nth term of a sequence, so the first thing I look for is what it goes up in. Now to get from 2 to 9 I add 7, to get from 9 to 16 I add 7, and to get from 16 to 23 I add 7. Now that tells me this sequence is similar to the 7 times table. So I start the sequence with 7n, and I put the 7 times table underneath the sequence. What I do now is I look for the difference between the 7 times table and the sequence that I've been given. So to get from 7 to 2, I have to take 5 away. To get from 14 to 9, I take 5 away. 21 to 16, take away 5. 28 to 23, take away 5. Therefore, the nth term of the sequence is 7n, take away 5. Let's look at one more then. What if we have 6, 11, 16, 21, etc. Well, again, the first thing I look for is what it goes up in, and 6 to 11 is plus 5, 11 to 16 is plus 5, 16 to 21 is plus 5. Therefore, this is similar to the 5 times table and starts with 5n. I write the 5 times table underneath, and I look for how I get from my times table to my sequence, which in this case is plus 1. So it's 5n plus 1. And we'll do one final sequence. So this time we'll look at 1, 4, 7, 10, etc. Now already we should start to remember the method we use, which is to look for the difference. So between 1 and 4 is plus 3, 4 and 7 is plus 3, 7 and 10 is plus 3, so it's similar to the 3 times table and begins with 3n. I write the 3 times table underneath, and I look for how I get from 3 to 1, which is of course take away 2. Therefore my sequence is given by the nth term of 3n minus 2.